We're now going to do the difference method to show that infinite sequences are monotone. So let's say we want monotone decreasing. That means our sequence A1, A2, A3, A4, dot, 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 AK, AK plus 1, and this goes on indefinitely. If it's monotone decreasing, this means that A sub k plus 1 is getting smaller than the one before it for all k values. 1, 2, 3, going on indefinitely. So we're going to subtract A sub k from both sides, and we get AK plus 1 minus A sub k will be less than 0 for all k values. 1, 2, 3, going on indefinitely. This is what we have to prove then, you guys. If we want to show monotone decreasing, we're going to have to prove that's true, not just for any two values of k, but for all. My example would be, let's look at the sequence 1 over n, as n goes from 1 to infinity. It's the sequence 1, 1/2, 1/3, 1/4, 1/5, and this goes on indefinitely. So my guess for this is, just looking at a few numbers, the first few terms, is that it is decreasing. But what I'm going to have to do is I'm going to have to prove this is true for all terms, k being 1 to infinity. So first I'm going to write, quiet, so with this one, we know AK plus 1. I plug in k plus 1 for n, and it's 1 over k plus 1. A sub k is plugging in k for n is 1 over k. So AK plus 1 minus A sub k becomes 1 over k plus 1 minus 1 over k. So now I'm going to write this as one fraction, so it's k minus 1 is minus 1 over the product. K times k plus 1. Right? And this is negative 1 over k times k plus 1. But because k is all values that are positive integers, this is positive, this is negative, so the result is less than 0. So we have just showed that this is negative for all values of k. And therefore, this sequence is actually monotone decreasing. The other one would be if we want monotone increasing. Instead of showing it's negative, we would show AK plus 1 minus A sub k. That would be positive, because this is getting greater. And we'd have to show that's true for all k values that are positive integers.